Hi, in this tutorial, I will provide an overview of a series of useful features in ParaView. So I will use the dataset that's provided in the GitHub directory, and also I'll be using ParaView 5.11.1. But this should be very similar for most versions of ParaView. Yeah. Okay, so when you load your data, you can open your data here into ParaView. If you want to load individual time steps, you can select the individual time step. But if you have a time series of files, when you want to load it, you can see that you have an option to just load the entire group here. And if you do so, here you'll have the option to navigate and play between different time steps. Okay, so let's go over the very basic features. So we can drag, rotate, we can zoom in to a file, we can visualize different parts, we can enter inside the even the geometry, we can see through the geometry if we like. So in this case, we're looking at through the aorta. When we load here on the top here, we can select the background color, so what color you want. So typically for creating figures, you want it to be a white color. And also you can turn on or off this orientation view, this axis. And then something very useful is when you load your data up here, you can select how you want to visualize it. So solid color will just be this solid color. You can change that by going under properties and edit. So you can tell it whatever color you like it to be. So I can change it, my model, to red. But then if you click here again, you can plot all the data that you have. So we have in this case volume, stress, velocity, pressure. So if I click on pressure, I can plot pressure. Okay, so I'm visualizing pressure right now. So when I load any model, it's pretty useful to look under information. So when you click information tab, you can see the path, you can see the file name, the type of grid, the number of cells. This is the total number of elements. In this case, tetrahedral elements, the number of points or nodes, and the bounds. So these bounds are the bounds for X, Y, Z in the data. And you can see the different data arrays we have. And for each of them, you can see the range. So if something here is a vector, you will see 3 ranges. So this first, for example, for velocity, this is the mean and max for X component and so forth for Y and Z. Okay, so this is always something very useful. We should always first look at whenever we load any data into ParaView. And then up here, we can select which ones we want to plot. We want to see volume, stress, or pressure. And also, we can turn on or off this color bar. And if you click on the edit color map, and then you click on this choose preset here, you can choose a different color set. For example, you can choose the turbo rainbow type color set. That looks a little bit more, it has a little more detailed information, which I usually prefer over the default color bar. And then you can also play around with this here as well. So for example, I'll come back to that later about one way we can play with this. So another useful thing up here is that the type of visualization you want to see. So if you click on outline, you'll just see an outline of your data, which is based on the bounds of your data. If you click on surface, just see it. It's typically how we would like to see our data. If you click on surface with edges, you will see the mesh on top as well. So you can see this is the surface mesh, the triangulated surface mesh that I have. Okay, so if I go back to solid color, I can visualize just my mesh. Then I can also have the option of visualizing as a wireframe, so something like this. But typically, we usually either visualize as a surface or surface with edges. These are the 2 very useful ways to visualize our data. And I'll talk about surface LIC visualization of vector fields in the next tutorial. Okay, so there's also one more useful way here that I forgot, and that's the volumetric visualization. So if you click volume, it typically takes a while to render depending on how big your data is, but it's a cool way to visualize your data in 3D. So it's usually a little bit buggy on different computers. So you can see what happened in my computer as I moved it along. But it's usually, if it works, it's again, it depending on if you try doing volume rendering, depending on the version of ParaView you use and the computer you use, you'll see some technical issues here and there. But volume rendering is usually something nice to do for with 3D visualization, and typically we do that and you can do that. You can apply that to the magnitude. So if you apply volume rendering to the velocity, it will not work because it's a vector. So you first need to calculate the magnitude of that using calculator, which I'll show you in the next tutorial. Okay, so then the most useful filters in ParaView are available already up here. But if you click on filters here and you go to alphabetical, you can see all the filters here. So this is pretty much everything that ParaView has. But the ones that are very useful are provided here. So calculator, which is a nice way to post-process your data. I'll talk about that in the next tutorial. Another one I want to talk about here is clip. So if you click on clip, then under properties, you can clip based on plane or sphere. So let's select sphere. So I can move my sphere and I can select, if I click apply, I'm going to clip my data. And I can, if I click the invert option, I can choose which side I want. So now you can see that under this list, a new instant of your data called clip is created, which I can turn it visualization on or off. And that's this part we clipped. So if you like to just save this data, you do file, save data, and then you select a VTU or VTK format and you save your data. So this is pretty much anything we'll do in this tutorial. You'll be able to click on it, the last product, and save it. And sometimes you want to do multiple sets of these. So you do a clip based on this sphere. You can turn the sphere off too. Then you might want to do another clip, this time based on a plane. So let me select a plane, for example, like that, then apply. I can turn the plane off. So if I get something like this, and I might want to do this multiple times and then save my data. So for example, I might be interested in a certain region of interest. Okay, so then another nice thing besides clip here is the slice filter here, which if you click on slice, it will just slice your data. So I can select like a plane here, apply, and now you can see that I have a 2D cross section where I'm visualizing pressure. Okay. Now, another interesting thing to see is that when you're visualizing your data, this color bar here, you have different options to set this. One is if you click on the here on rescale to data range, it will just rescale it to mean and max of your data. The next option is to rescale it manually. So if you click on it here, you can set the mean and max values yourself. Okay, and then update this color bar visualization. The other one is rescale to data range over all time steps. So it takes the mean and max over all the files if you have a series of files loaded. And the last one, which I find very useful for quick visualization, is rescale to view. So let's say I'm only interested in this region. Okay, if I zoom into this region of my domain, it's all the same color. It doesn't give you much information, right? Because this color bar is set based on the entire range of data. So let me zoom in again. But I care about somehow, let's say, this region of interest. So this is a very useful feature here, which rescales to the parts of the data that you're looking at in your windows. If I click on this, so now you can see I have all this, blue to red spectrum appearing here. So now I can visualize my region of interest with a color bar range that's set to mean and max of my view. So this is mean and max of what I'm looking at in my screen. And I can log view out, so you can see the rest becomes a low value, so it's all dark blue. Okay, so this is, and then I can go back to, if I click this again, now it will be based on the entire model because I'm visualizing the entire model. Okay, so this is something I find very, very useful for when you're visualizing data. Okay, now another useful option is threshold. So if I click threshold, it only can be applied to pressure, to scalar, sorry, scalar data. So pressure is a scalar. So I set lower and upper bounds. I click apply. Now I threshold based on these bounds. If you want to apply threshold to velocity, you need to use the calculator. First, calculate the magnitude of velocity, and then apply threshold. Because threshold, I think it only works on scalar data. Okay. Then another useful feature here is glyph, which is very useful for visualizing either particle data. If you have poly data, you can use glyphs to visualize them as spheres. But in this case, where we have vector data, we want to use arrows to visualize the velocity vector field. So I want to scale it based on velocity. I want the orientation array to be velocity, and I apply. And I get these huge vector fields. And you can see that these vectors are colored by pressure. Let me color them by velocity. And then I can change the scale factor to get something reasonable. So now I get something reasonable by reducing the scale factor here. Now, visualizing vectors like this is a little bit tricky because you can see the small vectors, you don't see them, you only see the large ones. So in the next tutorial, I'll talk about how to more appropriately visualize vector fields. But one thing here to note is that by default, it only selects 5,000 of the nodes randomly and seeds these vector fields there. If you want to use all points, you can select all points, then apply. So now you can see glyphs on all points. It's probably not very useful because it's too big, but you can also select how often you want. So maybe every 5 nodes, I want to apply a glyph. I want to make it maybe a little bit smaller, set the scale factor a little bit smaller, so I can see my velocity vector fields. Okay, so I will be talking about vector field visualization in more detail in the next tutorial. Another interesting feature here is, so stream tracer is also for streamlines, which I'll talk about next. But then wrap by vector, this is something very useful for solid mechanics, especially when we have a solid mechanics data that we have a displacement field, which we solve from Cauchy's equation of motion using finite elements, and you want to deform the data according to that displacement field. So in fluid mechanics, perhaps we don't use it that much, but just to show you how this is used, let me calculate the normal vectors and deform my geometry based on the normal vectors. Okay. So now I'm going to show you how to calculate the normal vectors, which you already did, provided examples of that in the VTK examples. So here I will apply filters. And by the way, everything we're doing here is based on VTK, right? It's just PyTorch is a software package built based on VTK capabilities. So here we go to alphabetical filters. We first do extract surface because I can get normals off the surface. So if I click extract surface, apply. So now I only have the surface mesh. Okay. Then I go to filters again, alphabetical, and now I do generate surface normals. So if I go down, generate surface normals, apply. And I flip the normals because by default the normals are inward. I want them to be outward. Okay. And I can do a glyph to visualize them as well, but if you like to visualize your normal vectors. Now I want to move my mesh based on the normal vectors. So you can kind of guess what's going to happen. The geometry is going to expand uniformly everywhere. So I can do wrap by vector. I set the scale factor, how big I want to move this, how much I want to move this. And the vectors are not going to be velocity. I want to move the mesh based on my normal vector. Apply. You can see the mesh, the geometry got a little bit bigger. Hopefully you could see that. So let me make it a little bit even more bigger, so you can see that it's going to get a little bit some issues it's intersecting here, for example, but this shows you how your geometry moves. So let's say make it a little bit smaller, for example 0.7. So if this is my original geometry, I can expand it. Okay, so using the this filter warp by vector. Okay, now let's go over some of the other features that we have. So up here, you can also set your camera. If you want to save your camera view, you can save your camera view by here clicking on the camera, adjust camera, and then you can save the camera. There are some, you can select data points here too. One thing that I find very useful is going under File and Save State. So when you save state, it saves a very small file that essentially what that state file does is that it records everything you've done in ParaView. So once you go back and then you do load state and you load it, your window pops up that everything goes back exactly how you left off. So all these things you applied will, and even the view will go back to how you left it. So this is very useful when you're doing extensive work, for example, in creating figures for papers, okay? And even something nice about load state is that when you click load state, you will have then options when you actually click a state file, a PVSM file. If you don't, by default, it will load the same directory that the data sits on and apply all these filters to it. But you have an option in the newer versions of ParaView. It provides this option for you where you can select a different file. So you can select a different file or a different directory, a different file, and then apply the state file to that, and everything you've done, even the view, the coloring, everything will be applied to that file, okay, that other file. Okay, so now let's go over a series of these filters here and talk about some of them. So filters, alphabetical. Okay, so one thing is, so I'm going to just scroll down and talk about some of the more useful ones. One thing is cell data to point data. I find this very useful if you have data stored element-wise. Usually that leads to poor visualization if you have element-based data stored. And applying cell data to point data interpolates your data to point data visualization on the nodes and creates a much nicer visualization. So how do you know if your data is cell data or point data? If you click under information, here, if you see these dots, you can see that this data is node data. But if you see this kind of like cube figure here, you can see that this is element-based data. So in my example here, global element ID is defined element-based. Everything else I have here is defined node-based. So, I mean, you can also do the other way around, which is usually not useful for visualization, but maybe useful if you're doing element-based calculation. You can also go from node data to cell data, which is what I can do here because I have node data. So if I go to filter, select point data to cell data, point data. So if I find point data to cell data. Okay, here, apply. Now you can see my pressure is defined in you see all of my data are now defined element-based. So if I click here, if I zoom in, you can kind of see the visualization now, right? You can kind of see that I'm visualizing element by element. So if I bring surface with edges, you can see these triangulated elements, and you can see every element has a single color assigned to it in visualization. And so for visualization purposes, it's perhaps not as nice. I probably prefer to visualize like this because it's smoother. So you can see now I'm doing it node based. It's much smoother, nicer. So, but then these filters allow you to go back and forth. So if you have cell data, you can make it nicer by interpolating to nodes for visualization purposes. Or if you have node data, maybe you want to do some cell-based calculation, so you can go the other way around. Okay. So now let's see what else we can do here. Let's go back to filters, alphabetical. Another interesting feature is clean to grid. This is useful if you're having meshes that you're importing from ANSYS, for example. Sometimes their faces are duplicated, and sometimes using these filters helps if you want to convert a mesh from another software into it, okay? Another filter here, if we scroll down, is compute derivatives. So if I apply compute derivatives, it allows me to get out the scalar gradients, vorticity, or vector gradients, strain, rate type, so symmetric part of gradient of a vector, if you like. That's, I think, what strain does. And you can do all those sorts of calculations here and get the output. So we already did this using PyTorch in our PyTorch tutorial series before this. Okay. Another interesting thing is the connectivity filter. So for that, what I need to do is that I need to first get the surface normals, which I already did here for you in the previous case. So I did extract surface, then I got the surface normals. So once you have the surface normals, if you apply the connectivity filter to it, then you select apply, it will generate a new array for you called region ID. Now, what is this region ID? It think if you look at this, you can now guess. In this example, it's going between 0 to 3, so it's 4 different IDs. And it's assigning my inlet, my 2 outlets, and my no-slip wall. So that's pretty cool. So I could use this connectivity filter to tag with this region ID my inlets, outlets, and the no-slip wall. And when you do it in this process, keep in mind that the feature angle option you set in generate surface normals determines how sharp of this edge, how sharp it considers when it tries to distinguish between different faces. Now, why is this connectivity useful? Because, well, now you can apply threshold to that. Threshold region ID, let's say I select, I don't know, 3, the face 3. So I set my lower and upper bounds to 3. What did I get? So let me turn this on and off. So you can see I got one of my outlets. So I can now go and save this outlet here if I like to have this outlet. And I can also, so remember in my tutorials, I talked about having these global node IDs. And then, so for example, when I interpolated to a new velocity mesh, I already had these global node IDs. And then I had these faces that CMascular gave me with these global same IDs attached to the face mesh. So now if you don't have a mesh from CMascular, you could use these features. You could use take your 3D mesh. It has something called under filters called generate IDs. So you'll generate IDs for everything. And then you use connectivity to kind of take out different boundaries. And the IDs will be attached to it when you threshold out different boundaries and save them in different files. So you know within your global mesh, where does each node in this local face sit? So you can kind of create something similar to what CMascular creates if your mesh comes from something else, but you'd like to use the same functionality that we talked about in some of our previous tutorials. Great. Okay. Now, another thing that I feel like I should say is that when you visualize things here, you have an option to turn this to use opacity. That's another something very useful. So if you go to properties for anything, so let's say I'm visualizing the pressure field here. Opacity by default is set to 1, but if I reduce it, something like this will be created. So why is this useful? Well, let's say I want to slice my data. Okay, let me do it one more time. Slice my data. So I have this slice. Let's say I want to visualize this slice, but at the same time, I want to visualize my 3D model. So I can select my 3D, I can turn both of them on, but you can see I cannot see inside because this is blocking my view, but then I can set opacity. So if I make opacity lower, you can see now at the same time, I'm visualizing my 3D data and also the slice inside it. You can play with the opacity. So you can make the outside also be just a solid color, not necessarily pressure focus. Okay. Okay, so let's bring opacity back to what it was. So, another useful feature which needs to be applied to surface data. So by the way, these filters, you can see that sometimes some of them are active, some of them are not active, because depending on what you're clicking here, so in this case, I clicked on a surface mesh data, some of them could be applied to that type of data, some of them cannot. So for example, this next feature we want to talk about, which is decimate, I believe it only can apply to surface mesh data. So if I click on it, apply, what I can do is that with this one, I can change my mesh resolution. So if I do surface with edge visualization, you can see I can play with this factor and make my mesh coarser. Okay, so in this case, I made a very coarse mesh that kind of made a poorer geometry for me. Okay. But you have this option to do. Probably it's not the best surface mesh edit tools. You're probably better off using other open source software that are meant for editing mesh, STL based data. But it provides some of basic functionality. Okay, now another interesting feature. So if I go back, when I loaded my model, when I did a clip. Okay, so let me clip one more time as an example. And I apply clip. If I do surface with edges, it somehow brutally went through my mesh. So you can see that here, for example, at some point, I might no longer have a like here that I cut, I no longer have the triangular elements necessarily. Okay, so I cut through my elements. So there's another feature that doesn't cut through it. So by the way, if you want to cut through it like that, so sharp cut through your geometry, and you want to convert back to your mesh back to tetrahedral mesh, you can do the filter alphabetical and do tetrahedralize. So now it will tetrahedralize your mesh once again. Or if you have a surface mesh, there's the option triangulate, which will, when you crop the domain and you have like your triangles get cropped in between and you no longer have triangles at the boundaries that you cut your domain, you can apply the triangulate filter and generate triangles. But then there's another option you have, and that's this filter called extract cells by region. So if I apply that one, and let's say I select some plane here and apply. Now let's see what it did. So this one doesn't, it respects the elements. It doesn't cut through it. So you can see it preserves the elements that it has. So if I click surface with edges, I can clearly see my tetrahedral elements are preserved here. So I like this because this is a nice way for you to show a visualization of your mesh. So if you want to show your mesh in your paper, I think this is a nice way to do it. You could use extract cells by region and then apply surface with edges. And this is a nice visualization of your kind of like your 3D mesh that you could present in your paper. Okay, great. Then let's see what else we want to talk about today. So if you continue along filters, another nice feature is well, there are many features here. I'm skipping most of them. I'm just talking about the most useful basic ones. Mesh quality is another interesting thing that you can get some metrics of mesh quality if you apply it and then visualize those metrics of mesh quality on your mesh. And the last thing I want to talk about is plot over line. So this is another very useful thing. So here you can define the 2 points that define the line, or you can just drag these 2 points to where you like them to be. So let me make sure they're both inside, move them along. That is not inside yet, go in, okay. And if you like, you can make this opaque so you can see where your line is. Where did my plot over line go? Oh, I think I lost. Okay, there you go. Did I lose my line? Let me see. I think I should start over again. Okay, let's bring this back. So let's do one more time. So now one thing interesting is that when you go to filters, if you go to recent, you don't need to necessarily go to alphabetical and find your filter. If you click on recent, or you can also tag your favorite ones here, you can select the recent filters you use so you can more access them more quickly. Okay, so let me select the 2 points for my lines such that they fall inside my domain. So that's 1 point, other point. Okay, I think it's inside. Now I apply. And then what I can do, I can select the things I'd like to visualize. So in this case, I want to visualize pressure. So let me turn off everything else. So now you can see along this line, so these are the coordinates along the line, and the y-axis is the pressure. So I can visualize, generate these graphs for data along the points that's defined based on these 2 points. Okay. That's the main thing I wanted to talk about. And you can also, again, each of these you can save as VTK. So this plot over line, I think if you click on save data, you can save it as, I want to say you can save it as, comma CSV file. So I think you can easily load it into Excel or MATLAB and then, take this data and create a much nicer plot. And I don't normally like to use ParaView for generating plots for my figures. And I never do that like this for generating this type of plots. But if I ever want to use interpolate over line, I will export it as an Excel file and load it into MATLAB or Python and then do a much nicer plot. Maybe in the future, I'll create more tutorials about creating nice figures for papers. Okay. So with this, I think we provided a basic tutorial over the very basic functionalities and useful. No, I wouldn't say a lot of these things were pretty intermediate or advanced events, some of the things we talked about, but it's pretty nice that we can use to visualize our data, process our data, and create nice figures for our papers. So by the way, if you want to create figures for your papers, you usually want the background to be white. So just my recommendation is that your background be white. You turn off this orientation axis here, like that. The color bar, my recommendation with the color bar is that do not use it from ParaView. So turn it off and just save a figure of the color bar here and add these numbers yourself in whatever software you're using for creating your figures, like Inkscape. I will create a tutorial later about this. But then what you do is that, so let me turn off this, and then you create some, want to reduce white space. And then you use your white space like that, and you create, you do file, save screenshot, and then you can select the format you want to save your figure. So sometimes these white spaces are inevitable. You cannot necessarily remove them here. There are software and also Python scripts, some Python libraries that automatically remove these white spaces. Okay, I will be in the future. I will create a tutorial for how to do professional figures for papers using ParaView and Inkscape. And yeah, so this is concludes our tutorials for ParaView, and I hope you enjoy this.